Hello guys, welcome you all for this end-to-end AIML session where you're gonna learn everything that you guys need in order to become successful data scientists. And this program is going to be a year-long program. We're gonna cover in a breadth-wise manner, and then we're gonna move to the depth-wise manner. So we're gonna learn everything like a code-wise, theoretical-wise, and then concept-wise. Everything we're gonna learn from scratch. So hope you guys are enjoying. Please subscribe to our channel so that you doesn't miss any session. So please be prepared with all the sessions which are done in previous things so that you can have a better understanding of what we are saying now. Okay, so guys, in the previous session we have just looked into a unsupervised learning technique called as clustering, and we have looked into multiple kind of algorithms inside. Okay, today we're going to continue that. Okay, so that's the reason I'm just insisting you guys, please make sure that you guys have looked into all the previous video so that you can have a better understanding of what we are saying. Okay, so without wasting any time, just jump into the session. Okay, directly we're going to jump. So today we're going to see a DBSCAN clustering. Okay, it is one of the clustering technique. Let's see how it is going to work. Okay, so DBSCAN, density based spatial clustering of applications with noise, is a density based clustering algorithm that groups data based on their density. Guys, I hope you guys know about what is memory density. Okay, density means, I will put it in a simple manner, it is like a majority. Consider it is like a majority kind of thing. The thing is, it has different things. So from these three things we can understand this concept. Core points, points that have at least a minimum number of neighbor points within a specified radius. I will say one thing. How this K-Means, like this DBSCAN works means, they have a minimum neighbors, that is a nearest point. Consider we are having a point, and a point, in order to call it as a cluster, it should have at least 5 neighbors. That is closer to it. Okay, we are having a point, and around it it is having nearly 5 points. Then it is called as a cluster. Okay, that is called as a core point. The point which is center, or that 5 points becomes a cluster, right? The center point is called as a core point. Then comes to border points, the points that are not core points but are within the radius of the core points. Okay, we are having a point and 5 points are around it. These 5 points are called as a border point. Okay guys, I hope you guys are understanding. Next we are having noise points. Okay, points that are not core points or border points considered as an outlier or anomaly, that is called as a noise point. This is why we are just calling this algorithm is very helpful when you are going for predicting the anomaly or outlier detection, because whenever the point is now comes under this cluster or this core point or border point, then it becomes the outside, right? Then it is an outlier or anomaly. Okay, I hope that this is a very easy algorithm to explain. Okay, we are having a point. If it has a minimum number of neighbors, then it is called as a core point. The neighbors that are on the things that could called as a border point. The points which is outside this cluster is called as a noisy point or the outlier. Okay, I hope I have explained you in a simple manner. So yeah, that's from my side. Yeah, so over to you.
Yeah, so just a minute, guys. Yes. So DBSCAN clustering. DBSCAN clustering is density-based spatial clustering of application with noise. So this helps us in density-based. It's a density-based clustering algorithm which helps us that groups dataset points based on the density. It is based on the density, how much dense is the data points. Based on their density, we use this particular. That's why the name of algorithm is density based spatial clustering of application with noise. So core points are the point that have the at least a minimum number of neighbor points within a specific radius. As Raja already mentioned, we need to have 5 points so that we call it cluster, right? So uh, so we need to have minimum number of neighbor points within the specified radius. There's a limit to it. So it should be within a specified point. Okay. So that is the core points uh, within this density based spatial clustering. So Border points are points that are not core points. They are at the border. Huh? You understand border, right? Suppose we have a country, so core will be like the capital of it, Delhi, or the center of it, and then the borders would be the border areas, border points. Huh? Similarly, you can imagine points that are not core points. So border areas cannot be a core point, okay? And then, but within the radius of the core point. So, but they are within the radius of the core. Like the border states are within the country's region, right? So they would be called, you can't call a border area, it's not India. It is part of India. India is a union of states. So it is managed by Delhi at the center. So center, you can say the core, and border areas will be the border states. And this is how you can understand. Huh? And then you have noise point. Noise points are not the core points or the border point. They are not neither core nor the border, and they are the outliers and anomalies. Okay, consider outliers and anomalies. They are considered as the outliers and noise. So you have to see what is noise in your data. Noise can be biased data points which I somebody wants to influence. That can be noise. So you need to detect that noise, which is not true, which is not right. So outliers and anomalies. So whatever is your objective function of particular data, whatever model you're building, so noise can be non-relevant things, which are not related, which are influencing, which can be biased, outliers, anomalies. Core can be the core points which have minimum 5 neighbors, and then border will be they are not core but within radius of the core. They are within radius of the core, that's border. And noise is noise. You know what is noise? Noise is just noise. They have no value and no meaning for that particular objective function.
Okay, that's great. Okay, so yeah, this is what about this DBSCAN algorithm. Okay, let's move on to the next. Okay, yeah, Gaussian mixture model. Okay, actually, like this is a specific kind of thing that we are having for a clustering. It is somewhat, I will not say it is difficult, it is somewhat challenging to understand. Please make sure that you guys are able to understand this, because like it will be quite challenging. Okay, so Gaussian mixture model, GMM, is a probabilistic model that assumes the data points in each cluster follows the Gaussian distribution. Okay, so model estimation. The parameters of Gaussian distribution, such as the mean and covariance metrics, are estimated from the data. Okay, first of all, we need to estimate the mean and covariance metrics from the data. Cluster assignment. Each data point is assigned to the cluster whose Gaussian distribution has the highest probability density at that point. Okay, so and then what we do means, once we get the mean and covariance metrics of the data points, then what we need to, don't worry about the technical terms that we are speaking. Once we are moving on to the code and depth of it, you guys gonna learn this very easily. Okay, now understand, we are having a data set. From the data set, we need to find the mean and covariance metrics. It is a kind of a two different parameters concept. And how we can assign the data points to the cluster means, based on their normal distribution that has a high probability density, we are moving to the points to that cluster. Model evaluation. The performance of this GMM model is evaluated based on the metrics such as likelihood of the dataset under the model. Okay, okay, I will put it in a simple manner. It is a probabilistic model. Okay, like I hope. Okay, you guys are more. Whenever we are having a data set, consider we are randomly choosing that this data set is going to have a nearly like a 5 clusters. Okay, now I take a data point and I'm going to find, for this data point, for a single data point, what is the probability of belonging it to this 5 cluster. Cluster 1, what is the probability? 2, 3, 4, 5, whichever has a high probability, I'm going to pass this data point to that cluster. Okay, now I hope this is the easy explanation for this Gaussian mixture model. We take one data point and consider there are 5 clusters. We need to find the probability of this data point to belong to each of the cluster. Which cluster has the most probability or a high probability, we need to assign this data point to this cluster. Okay, so that's it. Okay. So I think this is a simple explanation I can tell for this Gaussian mixture model. So yeah, I hope you guys are understanding. So yes, sir, over to you.
Yeah. So Gaussian mixture model GMMS. So guys, so you understand it, it's a probabilistic model. They are probabilistic models that assume data points in each cluster follows a Gaussian distribution. Okay, so Gaussian was a scientist. He has created this. If you see, it is a they have created statistical models. Okay, so the if you understand the math of it, so you will go and understand. So he has worked a lot uh, on the predictor models and probabilities and probability create he created a lot of probabilistic models and stuff. So model estimation, the parameters of Gaussian distribution is such as the mean and convergence matrix. It's a convergence matrix which they estimate. Okay, estimate from the data. So it is a the parameters of Gaussian distribution is such that the mean and convergence matrix. So convergent mean and convergent matrix are estimated from the data. So this model is used to uh, in distribution, Gaussian distribution. This is a parameter where the parameters of such mean and convergent metrics are estimated from data. So we get from the data mean and convergent metrics when we use this model estimation. Okay, so it estimates the mean and convergent metrics from the data. Okay, then cluster assignments. So each data point is assigned to a cluster whose Gaussian distribution has the highest probability density at a point. So so each data point assigned to cluster, whatever cluster is there, it will provide it is assigned to a cluster whose distribution is highest in probability density, because it is for that. So you can see in the picture there's density yellow. If you see, there would be a point where you have a lot of density of yellow, but there would be points where you will have lesser, so when it goes towards border, right? Similarly, if you see in pink, there is a point where it is very highly dense, but then it is mixed with yellow or blue. So this is how you can understand the each data point assigned to a cluster whose Gaussian distribution has highest probability density at a point. So you have to see the highest. So that can be, so that only computer can determine. If you have billions of data sets, you human beings cannot determine what is the highest density, highest probability density. Yeah. So that is why Gaussian matrix models, they help us to they assign data point to such clusters. Okay, so model evaluation is the performance of GMM is evaluated based on metrics such as likelihood of data under the model. So it is probabilistic again, because guys, see, you have to see Gaussian matrix models. They it is on based on probability, so they are always probabilistic. You can't be 100% sure that this is the particular thing, but you will be at least 90-95% sure, rather than having no model where you don't have any guess that uh, what is the probability. Okay, so that is why we use these models. At least 90, 95, 98% will get a probabilistic view about the data, and the model will do that and will get the performance in the model. So we use this so then we have model evaluation. The performance of GMM is evaluated based on metrics such as likelihood of data under the model. Okay, so we are always probabilistic. Likelihood is probabilistic again, because we are not certain 100% that this is the thing. So we are always plus minus. in probability. So in today, see, we never, when you are in data science, you never say 100%, guys. Never say those terms. You always say probabilistic. So you when because when you go deep into data science and stat, you will say nothing is 100%. Nothing in this world is 100%. You are always probabilistic about the data or the models you use or the evaluation you do. You will never say I am 100%. And if it is real life, it is never 100%. It will need to have some kind of anomaly, some kind of outlier, some kind of um, uh, imperfection, and that keeps it going. That's a design of life. So that keeps it going. So some shells are vacant, so some improvement is needed everywhere. That's why we need to continuously even learn. We are never done. We have to continuously learn and upskill ourselves. So go deep into these concepts, and we'll apply them, and then you'll understand deeply. Right now, just understand the definition, absorb, digest, and then we'll do application. Thank you so much. Let's move to the other slide.
Yeah, sure, sir. Okay. Let's move to the next. Okay. I think hope you guys have understand how it is working, right? So we have seen about I think nearly three plus algorithms in clustering. Let us see how we can evaluate this clustering performance. Okay, evaluating the performance of clustering algorithm is crucial to ensure the quality and relevance of the resulting clusters. Okay, so you are getting a result and you don't know how to evaluate, then there is a no point of applying the algorithm to a data set, right? So you need to know how to evaluate this. Okay, first is we are having silver score. Okay, that's a score we can able to do evaluation for this clustering. So the thing is, it measures how well the data points is assigned to its cluster compared to the other data points. Okay, so other clusters. Okay, how well the data points is assigned to its cluster compared to the other data points, the other clusters. Okay, I'm again saying in the wrong way. Like how it measures how well a data point is assigned to its cluster compared to other clusters. Okay, this is what the silver score will tell. Okay, we are having a data point, it is in its own cluster where it should be, but how it is varying from other clusters, that is what the silver score. Then we are having Davis index, so it is a measure the radius within cluster distance to between cluster distance. Okay, we have a data points, how much it is its distance within cluster and how much is distance between clusters. Okay, that is one more thing. And then we are having another thing like calcium measured, like it is a measure, so it is another kind of a scientist who have an index, measures the radius of between cluster variance to within cluster variance. It is the opposite of before thing, right? Before it, Davis index, it is the measure the ratio of within cluster and between cluster. Here it is between cluster and within cluster. Guys, don't worry about these things because it all always it gonna be a single line of code. I think it is from a sklearn package. Okay, it is a machine learning package dot metrics. You just need to put sklearn dot metrics, import Silbert score, David score, and Callinson score. That's it. You doesn't need to think about anything. Okay, but have an understanding of what it is doing. If it is a silver score, it gonna find how much the data points belongs to this its own cluster and how it varies from other cluster. If it is a David score, it's a ratio of within cluster distance and between cluster distance, and vice versa for the Callinson index. Okay, just have an understanding. That's it. Okay, I'm not saying you should memorize this, but have an understanding. This is what this do. Okay, so yeah, sir, over to you.
Yeah. So evaluating clustering performance, guys. So we have these parameters which are very crucial to ensure quality and relevance of resulting in clusters. So metrics is Silvet score, which is like measures how well data point is assigned to a cluster compared to other clusters. So it compares. Okay, this is just it compares how well is data point assigned. This is what you need to understand. Silver score is just measures the how well data point is designed to cluster compares the other clusters. So assigned to cluster compared to other, how well it is assigned. That's it. Compared to other clusters. So it compares, I think, other clusters also and then gives a score. So Davis score indexes measures the ratio of within cluster distance. So between cluster distance, it measures the ratio within cluster distance between the cluster distances. So so it is called Davis index. So it measures the ratio within clusters. Within the clusters, there would be different clusters. We talk about there will be different clusters in the particular data, right? In the particular model. So the work of Davis index is to measure the ratio within the cluster distance to between cluster distances. So other it the see Silvet score helps us compares the data point assigned to other clusters. Here Davis does the ratio within cluster distance between other clusters and distance. That this is what it does. The data point assigned is Silvet score. Here Davis score is just the ratio within the cluster distance. It measures that between the cluster distances, right? So this is how you need to compare. Then uh, the third point we have is this measures the ratio between clusters variance within the cluster variance. So you can see there is a pattern in like Silvet score, Davis, or the third index which is there. So there is a pattern. If you see, the pattern is first one just measures the data points assigned to clusters compared the other clusters, right? Then second one measures the ratio within the cluster distance between the cluster distances. It measures the cluster distances, okay, between the other clusters, right? This is simple, you need to keep. And then third one is just ratio between cluster variance within the cluster variance. Cluster variance within the cluster variance. Like it's like we talk about data, then we talk about metadata, and then we talk about sub metadata. So uh, between metadata and sub metadata, what is the variance? So same that way you can understand. So it measures the ratio between cluster variance within the cluster variance within the cluster variance. So it becomes little. So we go at a meta to sub meta level. Like I'll tell you, when I was young, I used to think, oh, knowledge is knowledge. Whatever is in the books, you see that's knowledge. But when you start going deep, guys, so knowledge also has knowledge, and that knowledge also has knowledge. That's called deep learning. Like you go very in a network manner, in a bubble, in a crisscross manner, like neural network kind of thing happens with knowledge. You can generate a lot of insights, we go deep into it. So that is what, because why we have to understand it, because in the when the neural networks or all the models they work, so we have idea that okay, this measures the ratio between cluster variance to within the cluster variance, okay. And these are very thin lines, guys, to understand, because then you will have a feel of that okay, I am running this particular score or this particular index. So you know that how it feels like. So maybe you will not get 100% view how that black box works, but at least conceptually you are clear that what it is. So when somebody asks you, so you are not blank. You can give answer, okay, this is what I know, and just absorb it, digest it, and then do reinforced learning 5 to 10 times, understand these terminologies, watch all the previous session 5 to 10 times, then come to this session, then you'll understand what we are talking, okay. And build meta and deep sub meta level kind of knowledge body in you guys. Knowledge is not what is on surface level, that is just 1%, guys, okay. Knowledge is very very deep, and it has deep roots, huh? Every concept has that deep roots. So we need to go to the axiom level, the premise level, the basic concept of it. We need to understand. Then there is no problem. Then we can build our own concept, own algorithms, own models from scratch.
Yeah, guys. So that's it. Okay. So let's move on to the next thing. Okay. So yeah. So I think is going to be a last topic for this clustering. So application of clustering, guys. We have seen about different clusters and how to evaluate the cluster. Now let's see what are the applications of cluster. Cluster has a numerous application, like in various fields, includes data mining, machine learning, and artificial intelligence. So first is customer segmentation. Identify different customer group based on their buying habit and preferences. Okay, okay, we can consider like we are all learning data science, right? What is our preference? We would be buying a book related to data science. Okay, when someone is learning something like a electrical kind of thing, they're gonna not come and buy this data science book. So we can cluster the people based on their interest or preference. Okay, that is what the customer segmentation. Next, anomaly detection, detecting unusual data points or events that deviate from the normal patterns. Okay, if a person is not interested in data science or AIML, then the person is not going to be in this session. Okay, so that is what an anomaly. Okay, if that kind of person in this session means it's going to be anomaly. Okay, so then we are having image segmentation, dividing image into different regions based on the color, texture, or other features. Okay, it's major thing, guys. So we will be having an image. Consider I'm an image. Okay, let us consider it's a frame and it's an image. So based on the color means I think there is only like I think there is only four colors. It's a back. It is like a purple color, and my hair it will be a black color, and then brown my skin, and then again it is like a blue color. That's four color will be like this is how we can separate based on the cluster this image segmentation. And finally, we are having a document clustering, grouping similar documents based on their content and keywords. Okay, actually, this is like a bigger thing when it moves on to the LLM. This is one of the big thing now. Also, people are doing. Document clustering is based on the keywords. Like consider we are having a data science book and we are having some books related to Python. We are having a book on R. So uh, this is how we will cluster, right? Any keywords like we will be having keywords related to like data science kind of thing in data science book. But this Python and R we can cluster, right? Because like they are both are like a programming book. Okay, but this we cannot cluster. This is data science is a domain book. Okay, so like the data clustering till now it is working, guys. Okay, so like it is not limited to this. The application of clustering is not limited to this. There are n number of applications are available. We are just pointing out some of the very common and more usable applications. Okay, so that's from my side. Yeah, sir. Over to you.
Yes. So application of clustering, guys. So let us conclude this um, that where we can apply clustering. Okay. Clustering has numerous applications across various fields, including data science, machine learning, AI. Okay, we use it. That is why we are learning. Otherwise, we will not learn it. Okay, there is an application. That's why learning, and you have to understand each concept very clearly. Okay, Cu- customer segmentation. We apply it identifying different customer group based on their buying habits and preferences. So you've seen. So there were different clustering techniques which we had. So here we can apply them because first is cluster means a group. So based on different customer groups, what are their buying habit patterns and stuff. So that can be the different. There would be a cluster, and it will have sub. What you say the borders. Okay, it will have noise also. So we have to clean it. If we are not, so we need to get it cleaned by the algorithm and model, and we need to do all those things so that we get insights. Okay, that is the main purpose. We'll build model. So then anomaly detection, it detects the unusual data points, events, and which deviates from the normal patterns. Okay, so it helps us detecting the anomalies. So that's why it is very important, application of clustering. Then we have image segmentation. It divides images into different regions based on color, text, and other features. So it helps again us in image So that's why we use it in machine learning, even in deep learning also, images, na? So we use deep learning images, videos and stuff. Videos are, again, they are images, frames per second. So that they are just frames. Videos are nothing, they are frames. So ultimately it comes to images and pixels. Okay. So it divides into different regions and whatever. So it helps us image segmentation. Then document clustering, group similar document based on content and keywords. It also helps us in documents like finding the similarity based on content and keywords and stuff. So so application of clustering is very crucial, very important for us in AI ML data science and deep learning and AI. So that is why. So keep learning 5 to 10 times, watch all the previous sessions, and subscribe to our channel. Also press the bell icon so that you'll get the whenever new session is uploaded, you get the notification. And also give us the feedback how we can improve and bring more aspects, assets, more aesthetic, and more make it more simple and more engaging for you guys. So give us feedback so that we can keep improving ourselves and also the content and stuff, so that we are always relevant and you're learning very easily with simplicity. And keep learning deeply, have consistency, persistency, and have a deep big goal of life. Have short-term goal and long-term goal, and keep learning, deepening your skills, and learn meta and sub-meta, and go deeper into specialization. But first, let's do breadth first search, understand AI end-to-end, AI ML, and data science. Then we'll go deep into it. Keep learning. Thanks.
Yeah, guys. So that's it for this session. Hope you guys have enjoyed everything. So we will meet in the next session. Until then, take care, guys. Bye. We will meet in the next session. Bye, guys.